There we go. So hello, everyone. Welcome to the February 2026 Carbon Leadership Forum of Boston Northeast Reuse Subcommittee Group meeting. Today, we are happy to bring in Pixelframe. So we got Inge and Jenna here out of MIT to talk about a really cool solution for concrete, looking to be much more circular. And afterwards, the presentation will hold a Q&A, and then we'll give some simple updates about where we're going from this. Olivia, before the presentation, anything for the group?
Our theme that we're trying to go to this year is actionable items. So things that can happen and are really happening. We're past the theory of why we should do this. So you're kicking us off.
Yeah, very, very
Awesome.
exciting.
And how much time do we have, just as a reminder, so we can try and stay on schedule?
Try to like 1:40-ish if you want to kind of wrap it up. We'll leave for 10, 15 minutes of Q&A if
Okay.
that works.
Yeah, that's totally doable.
Sure.
Just wanted to make sure it wasn't like 15 minutes.
Yeah, no worries.
Okay, perfect. I'll share my screen then. And I'm in Austria, so I'm single screening it. Apologies for any technical difficulties because of that.
It looks great.
Awesome.
Looks exactly how it should. So we're going to present a little bit about Pixelframe, a smart grid of parts for the circular economy. And on the next slide, you can see our team. We're an interdisciplinary group of designers, engineers, architects, and we have been working on this project. Inge did a little bit of a preview of this while people were still joining the call, but Pixelframe first started at MIT as a research project in the building technology department, where we were working on the segmental design for a reusable concrete beam. That was the start to our project, and it's sort of grown from there. We've been working on it for the past 4 years, and working our way up in scale. So we did some half scale prototyping while we were at MIT, and have recently spun out the project with the assistance from a Catalyst grant from the Massachusetts Clean Energy Center, which has allowed us to move forward with prototyping at full scale.
We're going to play this quick video here, which shows our motivation. Probably fairly familiar to many of you, but it's still kind of nice to package it in a video. So Pixelframe kind of deals with the reality of building construction increasing rapidly, with the demand for concrete also increasing at a kind of similar pace. Much of the demand for new buildings will come in the form of concrete, especially in the global south and in Asia. So much so that the total mass of concrete will outweigh the total living biomass on Earth. And concrete, the extraction of the materials in concrete is kind of very polluting and damaging to the landscape. And it creates concrete. 8% of global carbon emissions can be attributed to concrete. We'll talk a little bit more about the inefficiency of concrete, but there is significant overdesign. Construction sites are disorganized and expensive, also creating another layer of inefficiency. And there's kind of a very much baked in resistance to new ways of building. And concrete buildings don't last very long. And because of this the short service life, construction and demolition waste really fills up landfills quite rapidly. So Pixelframe's really responding to this idea that concrete building and concrete construction has not reacted appropriately to the exigencies of the climate emergency that we're in. Sorry, here we go. So we wanted to do something a little bit different for this presentation. Typically, we have this very polished pitch that we give people, but we decided that since we're in a group of experts, we wanted to, rather than doing our typical pitch, we wanted to talk through this white paper that we published in the fall, actually with Eric's help. Some of you might know Eric. So this was part of our Massachusetts Clean Energy Center grant deliverable. They wanted us to also look at the business case, not just look at the technology, which makes sense. So we just come out of this academic environment. And so this was very new to us, looking at the business challenge for concrete reuse. But as everyone in the room knows, we have to make it work in our existing economic environment in order to scale. So we wanted to kind of talk through those challenges and explain Pixelframe through those challenges rather than just explaining the technology as is. So what we discovered, or I mean, the way we framed it was that there are inefficiencies on two timescales. And this is because one of the primary differences between buildings in the circular economy and other products like iPhones is the long service life or the length of the use phase of buildings. Buildings can last centuries when built and maintained correctly, and that's obviously the goal. We want buildings to last as long as possible. So on the kind of first lifetime scale, we found that concrete's inefficiency occurs in two different ways. There's the design inefficiency, which comes from engineering code requirements and kind of conservative design practices. And then there's the waste that happens during construction. So there's these multiple layers of inefficiency. And then we have a second life inefficiency. Paradoxically, concrete is a very durable material, but there's increasing evidence that concrete buildings fall into obsolescence faster than wood construction. So there's a kind of mismatch between the longevity of the material and the economic life of the building. And this means that there's a huge amount of concrete outflow coming out of our building stock, an estimated 360 million tons of concrete in the US in 2021. And if you look at that tiny little line at the bottom, you can see that amount of concrete that is actually reused, at least, or in 2021, that's the amount of concrete that was reused. And what's important to mention there is that this reuse is aggregate reuse, which is a form of downcycling. So it can only ever address 2% of the carbon emissions from concrete construction. And typically it's actually more carbon intensive to reuse aggregate than to just quarry it because the kind of processes are so efficient already for the quarrying of stone. Concrete is truly an extremely linear building material. So this kind of framing brought us to the idea of resource efficient design, a paradigm that we called redesign, which links the immediate urgency for materially lean construction with design for reuse. So it's trying to be resource conscious in the present and future and kind of really expanding design to a whole life cycle design rather than just worrying about the first life cycle. And the way this is accomplished is shown in this diagram here, which is from a forthcoming paper. We have the kind of demand side. Sorry, it's all demand side, but we use demand reduction through material efficiency, lifespan extension, and reuse. So at the beginning of the building process, we have things like material efficiency, so doing the same thing with less material substitution, subbing out lower carbon material for high carbon materials. Then we have the kind of looping back in of reuse, which is where Pixelframe came from. And then we also have lifespan extension, so just making things that can last longer. And I won't go into too much details of these pillars, but basically these are the different pillars of redesign. They range from the kind of material scale to the scale of the whole building layout, and kind of looking at the whole life cycle of concrete rather than just the first life. And in our white paper, we found 6 key challenges, kind of trying to integrate the design of Pixelframe and the design ethos into the real world of an economy where things have to compete financially. And we wanted to talk about 4 of them today. So those are a lack of innovation, sector inertia, financial strategic uncertainty, and mismatch of supply and demand. So we'll get into a little bit more detail on those.
And I'll give Inge a break from talking to introduce the first challenge that we wanted to sort of talk through with you all today, which is a lack of innovation, and specifically in the design of concrete. And while the construction industry has made strides in developing low carbon mixes and carbon capture technologies, when developing this white paper, we found that interviewees identified a real lack of innovation in circular concrete product offerings and noted an absence in digital tools to help manage those circular materials. So concrete building design has really not changed significantly since the invention of reinforced concrete. And often specifying a low carbon concrete through material substitution is a more accessible solution than following the sort of DFD design for disassembly design imperative, at the building component level. So sorry, I have a little more on that. I have a lot to say about concrete buildings, apparently. So most current circular solutions currently involve concrete recycling or material substitution, which at times can be more expensive than just landfilling the material. And modular DFD products are becoming more prevalent, but innovation in the design of concrete structures themselves has primarily focused on 3D printing methods. customizable building methods that employ redesign strategies remain costly and often difficult to scale. And there's a tension between the sort of like mass customization provided by something like 3D printed and the reuse potential of a modular system that's designed for reuse. So Pixelframe is reinventing design with concrete by explicitly designing for the twin aims of reuse and material efficiency upfront. And I can talk over this next video just to give you guys an overview of the system. So the system is all based around a single fiber reinforced precast concrete module. That's the pixel that you see floating around there. And those modules are assembled into segments and linked together into full-length structural elements. The same pixels are used to produce both column and beam elements, which are axially post-tensioned to ensure monolithic behavior. And then the beam elements also have deviated external post-tensioning to create a bit more moment resistance in the element. It's a modular system. You can see how it fits together here, and the benefit that we're seeing for prefabrication of the elements at full scale is the speed with which you can construct. So we recently finished a full-scale beam prototype that was assembled and disassembled in under half an hour. So it's really exciting to see that 3D puzzle is relatively easy to put together. And so this is sort of like the big metrics that we have for our system. Using just a typical off-the-shelf concrete mix, we're able to use 86% less material and have 80% lower carbon emissions when compared to a traditional reinforced concrete frame. And a key part of the reinvention of concrete is the leveraging of digital tools. So a lot of our work is hinging on the use of material passports, which is just this digital record that documents the materials or components and products used in a building or object, detailing whatever data is essential for the use of that product. And Inge's playing a video of our online material database or material bank that was debuted at our installation at the Venice Biennale last year, where we have this sort of online inventory of all of the pixels currently in circulation, and you're able to see their module location, usage, carbon history, and this data feeds into the back end of our computational design methodology we've developed to optimally assign pixels to ideal locations in a structure.
And what was really cool about developing this interface is we've always been interested in material banks, and it's always been a kind of side project. But then when we were building our beam for the exhibition, we actually used it to build the beam to find some key information. So it was really cool to do the exhibition as a kind of proof of concept for the material passport back end. So we'll move on to the next challenge, which is sector inertia. So what the main kind of breaking that down, the main things are that circular solutions are perceived to be risky. When we implement circularity at scale, we need new processes, and this creates complexity. Kind of initially learning new things, kind of reskilling that has to happen with labor and new know-how, but also kind of touching on what Jenna just talked about, which is the implementation of new tools to manage the complexity of like always having to know what's in your building stock and how you can use it. So what we're trying to do here is basically de-risk circular design with concrete in order to make it happen. So the first way we're doing this is integrating into existing supply chains. So we're working directly with precasters. And this has been something that's really interesting for us because what we're learning is that there is a kind of considerable excess capacity in the precast sector in North America. And there's an existing workflow where standardized products are made with that excess capacity, but the market for those standardized products is pretty small. So we're talking about things like highway barriers, these products that they can kind of just churn out in their free time with extra material. So we're integrating into that existing capacity, and there seems to be quite a lot of potential there. Jen already touched on speed, and so the second point I wanted to touch on is prefabrication. It allows for improved predictability and speed, and therefore cost savings. This is something that's more and more in demand as construction, material, and labor costs rise. It can make or break a project. So this is one way we reduce on-site labor. we've been working very closely with precasters and engineers. So here's a picture of the Pixelframe beam, the most recent iteration of it at Amrise at a precast plant. So we're working very closely with precasters and engineers in order to kind of tune the design of the system to work with their constraints. And one interesting example that happened recently was we were discussing the kind of typical pre-stressing process for concrete elements. And we worked through how to rethink the pre-stressing process in a way that's safe for deconstruction. So you can't use typical pre-stressing strand because it's quite dangerous to disassemble. So these are just ways that the constraints of the existing precast market and the engineering environment are informing our design. And we've felt very lucky to have the funding to kind of have these explorations with industry partners. Jenna already mentioned digital tools. This is also something that we see as a de-risking, the implementation of these tools to manage your inventory and to kind of have better control over what's out there. That's been a key part of our value proposition.
And one of the next challenge we wanted to talk about was the sort of mismatch between supply and demand. So during the development of this white paper, when we were talking to architects who were interested in specifying circular products, one of the biggest challenges that people were describing that they faced was how hard it was to specify non-standard materials when using just our typical construction and design processes that rely ultimately on standardization. And ultimately demand for new construction materials, just to keep pace with the rate at which we're building, exceeds that of available end-of-life materials, able to be used, like this active inventory that we have in the circular economy. And so this is something that we're also addressing using digital tools. So algorithmic design allows us to match the design space of buildings or parameters like bay widths, tributary areas to an existing inventory. And there's an interesting design problem that emerges here when you're designing a structure to best align with an existing inventory while managing programmatic requirements. And one of the benefits afforded by design for reuse rather than strictly salvage reuse is that you have control over your building blocks. So Pixelframe modules are standardized, which inherently increases their reuse potential. And this base unit can be used interchangeably to form different combinations and orientations to create beam and column elements with variable cross section. So this interchangeability specifically maximizes adaptability while reducing overall inventory complexity.
And that brings us to our final challenge, which is the biggest one and kind of the elephant in the room oftentimes when we talk about circularity, which is that across the board, everybody that we interviewed for this white paper mentioned that nobody is willing to pay extra for circular solutions. So for Pixelframe, what this means is that we have to be price competitive upon first life, which is quite challenging because design for disassembly is almost always an add-on. It's not something that is a reduction. So it's something you're adding on top of the existing system. And concrete obviously is a liquid material. It's cast once. So it's very challenging to make concrete circular and also price competitive. And also this break even cannot hinge on a future ROI. So, in some markets, there are buyback schemes or deposits potentially for bottles. But the Pixelframe business challenges cannot hinge on any kind of future ROI. The final challenge there is that there's no guarantee for future ROI or carbon savings for second life materials, especially when we're talking about a use phase that is in the decades or, the high decades. So that made it very challenging from the beginning. So finally, we'll talk about a few ways that we're reducing the cost of Pixelframe, or we're kind of leveraging design for disassembly to reduce cost in order to make it price competitive upon first life. We're still very much in the middle of this Pixelframe business case, but I think we're kind of hitting the midpoint now. And what we're seeing is that it looks like we are price competitive with typical construction and with precast concrete. So we're really excited about kind of further developing this. So the standardization that Jenna mentioned also lends itself really well to cost reductions in terms of module storage. The modules are stackable. The actual length of the modules actually comes from the constraint for handling them manually, which reduces equipment cost. So it allows for efficient storage and transport. Prefabrication and the kind of availability of offsite disassembly and assembly also allows us to speed up construction and disassembly times. I think this gets especially interesting for disassembly. It doesn't all have to happen on site, and it can kind of bypass salvage to some degree. We've always intended the system to be plug and play, so we're working really hard to design it to interface with business as usual foundations, envelopes, and secondary structural systems. And a key part of the design is the idea of material separation. So tips oftentimes with salvage reuse, there's a kind of complicated mechanical process for separating the different materials in a building envelope or in a building structure. Pixelframe has always been designed to be totally dry jointed and demountable, so you can just separate, you can detension the elements and separate everything very easily. This helps with efficiency and also helps to reduce labor times. So I hope that wasn't too confusing. We're kind of peppering the design motivation for Pixelframe into the different challenges we're discussing, but we wanted to try out a format where we address those challenges more directly. But from here, we'll move on to the future of Pixelframe because we have kind of a lot planned.
Yeah, so we recently concluded the development of our first full-scale element prototype as part of our Mass CEC Catalyst Grant scope, which we've been mentioning. And for the production of that prototype, we partnered with the precast company Amrise to produce the precast modules themselves and assemble the beam in an industrial environment. And this was a really great opportunity to not only test the design of the system, but the feasibility of the production at scale using existing fabrication workflows. And so our partnership with Amrise has been really productive, and we're continuing our work with them to discuss long-term commercialization and produce a full-scale demonstration structure.
So something that's interesting about that is that our partnership with them has always been under the auspices of commercialization. So they've been one of our main motivators to really think about the first life business case and not just the kind of ambition, the ESG ambitions of reuse and circularity.
And right now, or actually, yes, I guess yesterday, the full-scale primary beam prototype that was produced was on its way to the heavy structures lab at the University of Manitoba to undergo structural testing, which is going to help us align our engineering models to the system's real-life behavior. So we have scheduled a 4-point bending test taking place next Wednesday. Very excited. And more long-term, we're working with several partners to develop pilot and demonstration opportunities to showcase Pixelframe in full-scale building applications, ranging from utility buildings to multifamily housing.
So that's all we have right now. I see we made it through pretty briefly, so we're excited to have some discussion. We wanted to plug one thing really quickly. I think we already mentioned that we have some team members from the BART MBA consulting project here. And they're doing a really exciting consulting project with us that looks at the second life value proposition for concrete components designed for reuse. We have a team working on the first life business proposition, and that's the thing that's really kind of driving the feasibility of Pixelframe right now. It has to be competitive first life, like we mentioned in the presentation. But these students are specifically looking at the second life value proposition, which has been really exciting for us because it really requires a kind of rethinking of business as usual in the building construction industry. And they're in a phase where they're doing interviews. They've already done a bunch of exciting interviews. We talked about them today, but if anybody here identifies with any of those bullet points here, we're still really excited to interview some more people. So I've put my email and Tenny's email on here, and the interviews are about 15 to 30 minutes. Tenny, I don't know if you want to add anything to what I just said.
No, I think that's really great. Please feel free to contact me if you are interested in having an interview with myself or one of my team members. The way it'll work is you will contact me, and I will just shoot you out to whatever team member corresponds with whatever specific industry you're into, which is either developers, contractors, policymakers, or anything else. And then my team members or myself will take it from there in terms of scheduling. But we are really eager to connect with all of you. If you have any more insights that you'd like to share, we are just trying to get a better understanding on how to assist Pixelframe and understanding where they can sort of lie in the market, what is in the market already in terms of deconstruction, disassembly, policy nationwide that can support them. So yeah, thank you so much.
Yeah, I learned a bunch about policy in New Mexico today, and I was like, we definitely need some Massachusetts or New York State representation here because it seemed like a very different landscape.
Well, thank you. We'll move to Q&A, and I'll say to anyone as part of the group, if you have a question, you can use the raise hand feature. As always, I have a couple questions, but to anyone out there, welcome the questions. To start off, though, right now, I think construction is very defined in roles, especially in this area. I mean, you're talking to a contractor. There's a very union mentality of this is exactly who owns and does this, and that. So I think for installing the Pixelframe system makes a lot of sense. But if you're going to eventually deconstruct it, hopefully not demolish it and pull it apart. Is there a need for specialized deconstructors, or is there like educational services that you would provide to say this is exactly how you would go about taking this apart?
Jenna, I don't know if you have an immediate answer to that. I think what we're learning is that the less on-site labor time there is in terms of general labor, the better it is from a business standpoint. That might be a little bit separate from the union question. I think that the way we've mapped this out is kind of providing educational content for the disassembly, like the kind of unbolting and demounting of the elements, which doesn't require any like specialized tools or labor necessarily. From there on, they kind of go to a central headquarters where they can be disassembled, but that process itself is also relatively non-specialized. It just, I think, is a little bit more efficient in a factory or plant environment.
Yeah, something that's come up in our prototyping with AmRise is just how useful it will be long term and at sort of like a larger scale of production to not only prefabricate all the elements, but pre-assemble the elements in a factory setting. And so what Inge is describing is a model where the elements themselves could be delivered to a site for construction or taken away from a site after deconstruction. So just the demounting or like disconnection of the column and beam elements would be the element of deconstruction that would need to be taught on site. But that's not to say that an on-site assembly or disassembly or prefabrication model is impossible. It just seems like factory pre-assembly seems to be like the most efficient way moving forward.
Sure. Yeah, and I think so. With the kind of my question, there's going to be trade partners who go into typically right now. If I want to demolish a building that is full of concrete, they're going to probably go break everything up, try to do as fast as possible, and this just requires a bit more. Obviously, back-end knowledge to know that, hey, there's a system in place here that is atypical, as well as you had mentioned the database that you're kind of linking all of these parts and pieces in. Is the hope that not only this database continues to grow as Pixelframe looks to grow and I imagine become more sophisticated, but then as your system is deconstructed and disassembled, that whoever was owning that project is going to feed that data back in so you can recapture that and know that?
Yeah, I mean, I think the idea is that the data is always there. It never has to be like obtained. That's one of the hardest parts of salvage reuse is kind of obtaining the data of what you have. And there's lots of startups and research looking at that kind of that process, which we're trying to kind of circumvent entirely. And one of the main ideas is that you don't have a long lag period between the disassembly of the building and the construction of something new, because especially in high real estate cost markets, like the actual storage of these units can be a deal breaker in terms of the economic case for something like that. So we're also hoping to like be able to anticipate deconstruction and know exactly what is in a building and be able to kind of deploy that as quickly as possible. That's the long-term hope.
Very interesting. Yeah, the typical problems that we've discussed in this group before of space, storage space, and technology seemingly kind of are throughout this whole industry, but having the technology there and then hoping to be able to get in on the space early so that there's almost not really a need for it because you can move so quickly. Very, very interesting. I only have one more question. Once again, anyone in the crowd, if you'd like to raise your hand. But the CLF Boston Concrete Group has had a bunch of different groups on pushing low embodied carbon concrete. So precast concrete is fundamentally part of your system. Is right now the Pixelframe system using very low embodied carbon concrete, or is there a hope to kind of work with it? I know you said you were working with AmRise. I don't know if they have a hyper low embodied carbon that they're trying to put into it.
right now we're using relatively high embodied carbon concrete actually, and we're still seeing that 80% material and carbon reduction even with that like a typical high strength precast concrete mix. The system has always been designed to interface with the development of low carbon materials, but not rely on them. So we worked really hard to optimize the system materially based on the shape of the system rather than relying on low carbon materials. But obviously, if we're able to use low carbon concrete, our carbon savings are compounded. So that we're really excited about being able to use that. And you're absolutely right. Amrise has low carbon mixes that they're developing and using now. It's just a matter of how often they're using those mixes at the specific precast concrete plant that we're interacting with, honestly.
Yeah, one thing that we weren't super clear about is the fact that that embodied carbon reduction, I think it was 60 or 70%, that is first life. So that's before any reuse is even factored in. When we reuse it, we were seeing numbers that are up and like it kind of depends on the reclamation rate, which we're working out right now, but the numbers are in the 90%. So very, very high body carbon reduction. But like we said, we're finding that the reuse component is the Trojan horse that we sneak in with things like material efficiency and other kind of value propositions that don't directly address circularity. It's not something that's compelling enough on its own right now.
I'm curious if your system is basically categorized like another precast concrete system. And I'm thinking in terms of, for example, timber structures kind of had a hurdle of being allowed in code or being addressed, or whether structural engineering standards they work a certain way, and then whether or not this is categorized into something they do already, or if it will have the similar obstacles.
I can take a first pass at this question, Inge. We are currently designing to like typical concrete code standards. That being said, there's like obviously a hesitancy for adoption of new systems like this. And in that sense, it would still be very useful for us to develop some sort of like ICC compliance. I'm forgetting the name of like the bulletin that you produce and the process that you go through to create sort of like a stamp of approval from the ICC. But that's something that we're targeting once we finish our full-scale structural testing is starting that process and proving code compliance, because we have been keeping in standards with like Eurocode and FIB standards for concrete construction. So it's something that's definitely on the horizon to maintain that. I think that the harder challenge, the harder challenge beyond code compliance is developing the buy-in across the design process from everyone involved, right? So the deployment of a system like this relies on buy-in from the client, from the architect, from the engineer, and from the constructor. So I think that code compliance is just sort of like the baby step on the path towards construction. But it's definitely something that we are targeting.
I have more questions. Can your system be mixed and matched with other typical systems? Like if someone wants to try out using your system as columns, but then using steel beams as well.
Yeah, absolutely. And I think we have many different kind of demonstrator applications in the works, ranging from like a very large warehouse to demonstrating a single column or a small pavilion structure. We're still kind of actively working on many different pathways. I could definitely see something on the element scale happening before the full building scale, since we are still working on those engineering models, and there's a lot of trust that has to be established and testing that has to be done prior to the implementation of a full building.
And I know you mentioned you're looking for pilot projects. I was wondering if you could give further examples as like inspiration or to help people brainstorm what a good pilot project type might be for you.
Yeah. Jenna, do we want to show pictures or, I mean, so something we
I
didn't
can pull up
also
a
didn't
few.
get.
I can pull up a few pictures while you talk.
Yeah, something we didn't get into great detail into is that Pixelframe was developed as part of the MIT Climate and Sustainability Consortium, which is a kind of research consortium of industry partners. Initially, we were working with Holcim, another large multinational concrete company, but we also developed the system in close proximity with companies like Prologis and Amazon, who have these very large real estate portfolios. And in many ways, a system like this is very attractive to them because they manage their own building portfolios and their own construction. And they also have shorter service lives for their buildings. So we see utility buildings as actually like an extremely compelling use case for Pixelframe because we can get really, really long spans and tall columns for very little material and very little embodied carbon. These larger companies have very strong ESG mandates and shorter service lives, like I mentioned. So we're actually super excited about a potential utility building application. It's a little bit like, I don't know, most people don't want to build a warehouse, but we're very excited about that opportunity. We're also working with a company looking at housing. This would not be in North America, it's actually in South America where transport is a real constraint. So that's something exciting that's a little bit more speculative that we're working on. But I think in terms of like what's actually practical right now, we're really driving towards like a small temporary pavilion structure that potentially moves from one location to another just to demonstrate the kind of full building potential of Pixelframe.
Any questions from the group? One question I had, and kind of going off that pilot, what we're seeing, at least in this area, is I'll mention when we start talking about right when you got on the MIT structural steel. They had a bit of a tough time eventually getting into it, but they had found that municipalities like Cambridge were actually really interested in trying to, okay, well, what can we do at a very small scale? And with their, at times, very bold embodied carbon requirements, or at least where they want to get with their requirements, we're able to do this. Do you see, I guess I would ask both of you, how do you see that Pixelframe expanding in the next few years through pilot programs like this? Is there a desire to, you're working with Amrise right now and kind of learning with the white papers, where do you want to go in the next, say, 2 to 5 years with all of this? And do you think you can do it, given the current policy constraints, everything like that? That might be a loaded question, but because this group, we want action. And I think for the past couple of years, it has felt as if we constantly have these really good ideas, and we constantly have this software system that can really do something, or this project that really tried X, Y, Z. But it feels like a lot of those are either one-offs or don't catch fire. So seeing something like Pixelframe, which makes a lot of sense, of hey, we have this problem with concrete. We're trying a solution here. Here's a circular solution. Where do you, as the owners, the practitioners, really see it going in the future, and kind of how can you get there?
Yeah, I mean, Jen and I our goal is to build a building, and I think that the scale of that can vary. There's kind of a couple answers to that. There's Pixelframe as a startup. We found that there is an appetite to invest in a company such as Pixelframe. We're being cautious because we're not really at a point where we feel comfortable taking on dilutive investment. So we're mostly operating through grants, which has by nature quite limited. Then there's Pixelframe as a research project. We're really passionate about circularity and about kind of advancing the research. We have publications coming out. We're operating on the academic side as well. And then there's the kind of like industry collaboration that we're doing, and we're seeing that like concrete companies are really excited about this. They want to innovate. They want to try new things. Amrise is giving us an enormous amount of in-kind donations. They're very excited and very willing. But what we really need is like a pilot. We need somebody, a client who's willing to take on the risk of trying out something new. And that's been the most challenging thing, is that people are very excited about it. But when it comes to the first mover, that's been the biggest challenge for us, is getting people excited beyond kind of initial excitement and actually willing to pilot the system. So that's why we're kind of having to rely on things like mass catalysts to start building things at full scale. And we expect this to take a very long time, which is why we're working on the experimental validation. We have we have a numerical model and an FEA. We're working on all these different kind of engineering validation workflows. But I think we're going to get to a point where we're ready to scale and we're ready to build, but we just have to find that client that's willing to take the risk.
Yeah, John, I see there, but one thing I will say, so DCAM, the Department of Capital Asset Management, has a very ambitious circularity-based reuse pilot ideas as part of the embodied carbon policy omnibus that went through. So I think they're always looking, I don't think anyone from DCAM is on, but they're always looking for ideas to move towards circularity in their many projects across Mass. It might be worthwhile. I know they talked to the structural steel reuse, but something like this I think would be right up there, right in their ballpark of attempting these pilots and working with kind of these companies. John.
Yeah, thanks. Hey, just two quick questions. One, when you made the comparison against typical traditional concrete structural systems, did you include the floors? Were you including the floor assembly in there? I saw the floor, and then the Pixelframe had like a wood subfloor look down there. So is that reduction based on a model that uses like a concrete slab system versus like your beam system with a wood floor or something like that?
We've done comparisons on multiple levels. So we've done a sort of beam to beam efficiency comparison, where I think that the carbon and mass reduction was somewhere around 75%. We've done a system to system comparison, comparing Pixelframe to a full reinforced concrete frame, which is the image that we showed, where you're right on, the structural slab in a reinforced concrete system accounts for like 60% of the structural carbon. And so we used a CLT slab in our system comparison, because we have, in that instance, had much more tightly spaced secondary beams. We had smaller tributary areas. And that was the basis of that comparison. But even on an element level, beam to beam, the carbon savings are similar.
Great. And then one other quick thing, you mentioned spans, long spans. Like, what kind of spans are you talking with these beams? Like, what do you think of the max you could go? And then
right now, oh, sorry, go ahead.
No, I was just gonna pick one more thing, and then I'll go on mute. But you mentioned that they only had access to, is that not using low embodied carbon concrete because they don't have like silos and things set up to be able to batch low embodied carbon concrete, or are you thinking that, so we're seeing like positive and other stuff getting higher strengths for in the concrete, and it's just because they don't have that in silos that you're using the higher embodied carbon mixes? Or
we used the mix that we used was just determined by the sort of like ready mix standard set by this specific precast plant that we're in partnership with. I actually don't know what their supply chain looks like in terms of their low carbon mixes. It's something that we've talked a lot about with them. And future prototypes, we will be developing fiber reinforced mixes using that low carbon cement. It was just something that wasn't part of the
Gotcha.
fastest workflow that we were working with in the development of this full scale prototype. It happened like very, very slowly and then very, very quickly. So we were just sort of path of least resistance for whatever mix that they could get to work with our timeline.
There is a kind of tension between the goal. Like when we started working on Pixelframe, we wanted to use extremely low embodied carbon, low compressive strength concrete. But then when we actually started scaling and we were in a precast plant environment, we realized that they're using extremely high strength concrete because they want to demold every 24 hours. Obviously, stronger concrete, it's demolded way faster. And if they can't demold every 24 hours, the business case completely falls apart on their end for their precast product. So that's something that we had no idea about in working in an academic environment. And then we realized that it actually is almost impossible to get them to agree to use these slow curing concrete mixes where they would have to demold every 3 or 4 days. It's just kind of impossible from a business standpoint.
Yeah.
So what we're doing right now is we're tuning a mixed design that's financially feasible with their like demolding process with like whatever is the lowest embodied carbon that we can get.
Yeah, I hadn't considered that.
Yeah, it's
No,
kind
but
of an interesting thing that we learned.
yeah.
And to your other point about spans, so the system is parametric, and the design of the base module, sorry, is parametric so that it in itself is scalable. So right now we've just chosen a single size to move into production. This size is capable of spanning up to 15 meters with a series of typical live loading scenarios, like an office live loading scenario. The module that we currently have in production is capped at a 15-meter span, and columns are currently capped at 5-meter heights. And then we've also done some analysis about sort of like how many stories can you build on top of each other, and we're capping that around 8 stories for now, just based on the limitations of the structural analysis that we've completed. But like I said, it's parametric, so a bigger module can span further. A smaller module can span smaller distances with even lower carbon. So it's just about finding that sweet spot about like what's the most like useful size for right now.
Great, thank you.
Awesome. I'll say final call for questions as we're almost like win time.
I want to bring up that you partnered with this MBA program, slightly different from the technical side of what you're doing. And maybe I don't have a question, but kind of want to acknowledge that tying in of the economic side and getting next generation to think about the economics of circularity, and changing the way that businesses think about operations. So that's pretty exciting to me.
Yeah, it's been really fun for us. I mean, you kind of come out of school and you're like, I have this problem, like let me find this, or I have a solution, let me find the problem. So it's been almost interesting for us to reinvestigate some of those initial claims or initial ideas we had about how it would scale and address the reality of like what is in demand right now, but also kind of sometimes we end up challenging people because there is a lot of comfort in the status quo in the construction industry right now. So there does need to be a fair degree of disruption. So I think we see ourselves as something kind of in the middle. Like we are ultimately trying to scale Pixelframe. We're trying to build a Pixelframe building. So we have to operate within the real world of economic feasibility. But I also think we are trying to disrupt how circularity is seen with concrete because there really hasn't been very much innovation at all. And from a like lab standpoint, in our lab, there were at least 5 or 6 research projects that could get like 60% embodied carbon reductions in concrete systems. So there's no shortage of research about this. It's just there's kind of a gap between the lab and the market that we're sort of addressing with Pixelframe. And it's really hard, but it's also very rewarding.
Amazing. And once again, thank you, Inge and Jenna, for presenting today. I think solutions like this are very much needed, and hope that the group listening in could get some inspiration. I'm definitely going to share this as well with our CLF concrete group, I think who met yesterday or day before, because they have a lot of different structural engineers, different designers, and policymakers on there as well. I think it would be really good to hear all this. So thank you. We appreciate it.
Awesome. Thank you.
In the last minute or two, you'll see in the chat real quick, we put in again the link for the reuse roadmap version 2 survey. If everyone can take a look at that and give some inputs, whether you want to help know someone who does or just want to give some suggestions. I know this is a volunteer effort, but we really want to get a new version of that regional resource out. So please take a look at that. Oh, yes, and thank you, Jenna. Along with this presentation, we'll look to send out the recording and a recap next week. We'll also include the contacts for both Inge and Jenna, as well as some links. So thank you for that.
And we're happy to share slides as well, if that's useful.
Sure. Yeah, no, please send them to our CLF Boston Reuse Gmail. We'll look to send them all out. The only last thing I wanted to say is that either next month or the month after, we'll be looking to take a field trip. So I still have to circle back with Resource Roxbury. But in 2023, we took a field trip over to the RCI facility over in Roxbury. It was fantastic. We're looking to do that again. So in the coming months, we'll look to have all of that. But other than that, I don't really have anything. Olivia, anything?
That was it. Thank you for the presentation.
Yeah, no, we appreciate it. And hopefully it stops snowing so much around here. So thank you, everyone. You'll
Yep.
hear back from us. And once again, Pixelframe, thank you so much.
Thank you.
Well,
Have a
Have
good
a
one,
great
everyone.
weekend, everyone.